Okay, this is question on photosynthesis. So still, this is 2023 to I think 2020 selected question on photosynthesis. Now, the first question here is for us to complete the symbol equation for photosynthesis. Now, photosynthesis is 6 molecules of carbon dioxide plus 6 molecules of water. We give you glucose plus 6 molecules of oxygen. That's it. So the word equation is carbon dioxide plus water. We give you glucose plus oxygen. Now, figure 8 shows how the rate of photosynthesis changes with light intensity. Okay, now, so which part of the graph could be represented by this equation? Y is equal to mc squared. So it's the part that is rising. So it should be from here to here, can be represented with that equation. So that should be 0 to 5,000 or 5,000 logs. So this should be the answer. Now, a student investigated the effect of color of light on the rate of photosynthesis in leaves. Now, figure 9 shows how the investigation was set up. Okay, so we have sodium hydrogen carbonate solution that help to provide CO2. We have Dix cut from leaves. Okay, then we have a lamp that is the light source. Now, they said color of light, blue, green, red, and time taken for 10 leaf discs to reach the surface of the solution in seconds. Now, give one way the student could change the color of the light shining on the leaf discs is to just change the color of the bulb. Now, use a different color bulb. That's it. You can use a different color bulb if you want to change the color of the light. Use different color filters also in front of the lamp, any of the two. Now, give the independent variable and the dependent variable. I said it earlier, the independent variable is what you change. So what was being changed is color of light. What is being measured is your dependent variable, which is the time taken. So this will be your independent variable and this will be your dependent variable. Color of light, time taken for discs to reach the surface. So that's it. Now, all air all of the air had to be removed from the leaf discs before placing them in the beaker. Suggest why. So it will more like it will be fair, and there won't be any gas left in the discs for photosynthesis, so the air will not add to the volume of water that have been measured also. So any gas that makes the discs rise is from photosynthesis. Now, the leaf discs were placed in a beaker of sodium hydrogen carbonate solution. Explain why sodium hydrogen carbonate solution was used instead of water. Because sodium hydrogen carbonate provide carbon dioxide, which is used for photosynthesis. So the carbonate here, remember the carbonate here is carbon dioxide, which is used for photosynthesis. Now explain why the leaf discs moved to the surface of the solution during investigation. Now, it helped to show you that oxygen is being produced, or a gas is being trapped in during photosynthesis. So oxygen was produced in photosynthesis. That's why the discs moved to the surface. Now, there are two types of chlorophyll in leaves. Figure 10 shows the percentage of different wavelength of light that the two types of chlorophyll absorbed. So we have chlorophyll A, which is the dotted line, and we have chlorophyll B, which is the straight line, and we have wavelength of light and percentage of light absorbed. Now, the table shows the color of different wavelength of light. So color, violet, blue, blah, blah, blah. And the range of wavelength absorbed is this. Now, suggest the advantage to a plant of having two types of chlorophyll. So, two types means they'll absorb more light. So, rate of photosynthesis will be faster. Simple. It increases rate of photosynthesis because it absorbs more light. Now, color of light. Table 5 is represented below. We have color of light, blue, green, red. Time taken for photosynthesis to happen. So that same table is being repeated. Now the leaf discs in the investigation are green. Okay, now explain the result in table 5 for blue light and for green light. Use data from figure 10. So they want you to explain for blue light and for green light. So the rate of photosynthesis, or the time taken for the leaf to rise in green light, is higher than in blue light. So the rate of photosynthesis in green light is higher than that of blue light. Also, the time taken for discs to rise. Why did I say that? Why? Because the time taken for discs to rise in green light is, the rate of photosynthesis for blue light is higher than that of green light. Green light is lower. Why? Because the time taken for the discs to rise in blue light is shorter, which is 115 seconds, while for green light is 831 seconds. So chlorophyll absorb more or lots of blue light. So chlorophyll absorb least or very little or not much of green light. Yeah, so discs in blue light took the least time to rise to the surface because they photosynthesize faster. Or they photosynthesize more. So discs in green light took more time to rise to the surface because they photosynthesize slower. From figure 10 and table 6, you can see that. So approximately 80% of blue light is being absorbed, and the time taken is just 115 seconds. Now, the questions about photosynthesis, complete the word equation. I think I've done that earlier. Describe how energy from photosynthesis is gained by plants. That's light energy is captured by the chlorophyll, which is produced by chloroplast. So light energy is absorbed by chlorophyll. So that's it. Now, students investigated the effect of temperature on the rate of photosynthesis. Now, the students shone light from a lamp onto a pondweed and measure the volume of oxygen produced per hour. Now, table 1 shows the result. This is table 1, temperature in degrees Celsius. So this is your independent variable. What you are changing here is temperature, and this is your dependent variable. What you are measuring, rate of photosynthesis. So now the first question is, complete the mean value for x. So if you want to calculate the mean for x, you add the 3 tests and you divide by 3. So it will be 18.5 plus 19.3 plus 19.5 divided by 3. It will give you 19.1 centimeter per hour. That's it. Now, the student identify one error. Abnormalous result in table 1. In table 4, draw a ring around the abnormalous result. So if you look at this, the only one that is abnormalous is around 45 degrees Celsius and is test 2. When this is 2.2, 1.9, this is 14.2. So that's an abnormalous result. Now, suggest one possible cause of this abnormalous result. Possibly they added the temperature is lower than 45, or there are more pondweeds inside, whichever. So the lamp or the light was moved and the temperature was changed, so that can result in it. Now, how did the student deal with the abnormalous result? To deal with the abnormalous result, you don't use it to calculate the mean. So in this case, you can just calculate the mean with 2.2 plus 1.9 divided by 2 to get the mean, because this is is abnormalous. So do not use it in calculating mean. Now, give one factor the student should have kept constant in this investigation. Now, what they change is temperature. So things like pH, the species of the pondweed, all should be kept constant. The time should be kept constant. So you see, light intensity, the carbon dioxide concentration, the size of the weed, the species of the pond weed, all should be kept constant to make it a fair test. Now, here they said, why did the rate of photosynthesis decrease from 35 to 45 degrees Celsius? So from 35 to 45 degrees Celsius, remember the enzymes that help in the rate of photosynthesis will begin to denature. And once the enzyme denature, you find out that the active site will change shape. So there will be no substrate that we bond to it. So the rate of photosynthesis will decrease. Now complete figure 1 using data from table 1. Okay, table 1. So they've given us temperature here. So this, remember, this is your x-axis always. So your independent variable is always your x-axis. So this is x, so this will now be y, because we want to plot against the mean data. So all you need to write here for your y-axis, you need to label it. Use the y-axis. So I will now write mean. I'll write the mean rate. Trying to be fast. The mean rate of photosynthesis just copy everything in centimeter per hour, then label your x-axis. So the least value here we have is 2.1, and I told you always try to make sure it covers more than half of the space given. So the maximum value we are having here is around 44. So if I make this 5, 10, 15, 20, 25, 30, 35, 40. So that will go 5. Why is this thing doing this? 5, 10, 15, 20, 25, 30, 35, 40, 45. So I know my maximum value will fall. So it covers more than half. So if this is at 20 degrees Celsius, this should be 20 here. If this is 25, 30, come in. Here's the issue here. Okay, at 25 degrees Celsius, they didn't want us to plot for 20 then, because the difference here is 5. So at 25 degrees Celsius is 30. Let me see. It's 33.2. 25, this is 30, 31, 32, 33. At 30 degrees Celsius, it is 44, 40, 41, 42, 43, 44. At 35 degrees Celsius, it is 40.8, 35, 40, 40.8 is not up to 41. At 40 degrees Celsius, it is 22, 40, 21, 22, and at 45 is 2.1. So 1, 2. That's it. Plot the mean. Okay, we are done from 25 to 45. Okay, we've done this, we've done this, we've done this. So the last one is draw a line of best fit. So can just whichever. Now they said the equation about to complete the word equation, we've done that already. So take note, it comes out a lot. That's what it means. A student investigated photosynthesis using pondweed. Now figure 3 shows the apparatus the student used. Okay, now this is the method used. 1, set up the apparatus as shown in the figure, switch on the lamp. After 20 minutes, record the volume of oxygen collected in the measuring cylinder. Now, repeat step 1 to 3 for using bulbs of different output. So that was changed. What is the independent variable? Is the power of the bulb. That's it. That was changed using different intensity of bulbs. Now, suggest 2 ways the method could be improved so the result would be more valid. Now, anytime they ask you a question like this, the answer doesn't change. The method could be improved. 1, you can repeat the experiment and calculate the mean. Repeat the experiment and calculate mean, or you eliminate any form of abnormality. Now, control the water temperature. So the water temperature should be constant throughout the experiment. You can use a thermostatically controlled water bath, which will help you to control the temperature. Now, control the concentration of carbon dioxide. So the concentration of carbon dioxide should be the same all through. Now, table 3 shows the student result. Power output of bulb, volume of oxygen concentration in 20 minutes in cm cube, rate of photosynthesis. Okay, we have this, we have this, we have this. Now they say calculate the value of X in table 3. So if you look at this, this is 20 minutes and this is centimeter per hour. So for 20 minutes, you produce this. So in an hour, it will be what? So it will be 60 minutes, 1 hour is equal to 60 minutes. So if for 20 minutes, 160 divided by 20, we tell you how many, that's 3. So you understand that if for 20 minutes you produce this, for 1 hour you produce 1.1 times 3, which will give you 3.3. That's it in hours. Now use the x-axis, use a suitable scale, plot the data in table this and your answer to question this. Draw a line of best fit. Rate of photosynthesis have been here in centimeter per hour. So all we need is to label our x-axis, which will be power, which will be this one. That's your x-axis. So that will be power output of bulb in watts. Now this is up to 250, so I can just say 50, 100, 150, 200, 250. Bam. Let me see. 50, 100, 150. Sorry, this here should be 250, not here should be 250. So once you've done that, is what is left is to plot. That's all. So how do you even know? The difference here is 50 and there are 10 boxes. If the difference is 50 and there are 10 boxes, you divide by 10. So you know each box will be 5. So here, this will be 55, 60. So at 60, in an hour is 1.5. So this is 1. This will be 1.5 here. At 100, it is 2.4. 100, this is 2. 2.4. At 150, it is 3.3 in our answer. 150, it is 3. At 200, it's 3.6. It's 3.5, 3.6. At 250, it is 3.6 also. Line of best fit. Sorry, I can't really draw it properly. My hand is... So just make sure you touch the line that touches most of the X, the plotted dot. Now determine the expected rate of photosynthesis when the bulb is at 75 watts. So at 75, this is 75 will be here. So if this is 75, all you need to do is trace it to where it touches your line of best fit. So if I trace it down, it touches the line here. I take my reading, that's 20. So you can just come, and put in your 20 there. Now they say which graph shows the effect of temperature on the rate of photosynthesis. So obviously it is this graph here, because rate of photosynthesis and temperature, as temperature increases, the rate of photosynthesis increases up to like 37 degrees Celsius. Then further increase, the rate of photosynthesis will decrease because the enzyme responsible for photosynthesis have denatured. That's it. So thank you. I think we're done with this aspect on photosynthesis.